First of all, welcoming everybody that's here so far. I'm guessing some others might drop in later on as we get going. But thanks for coming to this product fundamentals session from Code, part of our product love series that we're doing. There's a range of these that are going to be we're going to be doing over the next month, which I'll cover off very shortly. Just an introduction to myself. My name's Dave. I'm technical director at Code. Been in the digital software industry for over 25 years and spent a large part of my history and learning my trade in pureplay.coms. But I came from a software development background, originally actually an electronics engineer who fell into software. Don't ask me how that happened. But ultimately that's led me down a path in technical leadership, head of delivery, head of engineering, architecture, and also technical strategy. So I've been doing a lot of this role at Code is around helping our clients to think about technical strategy and do it differently rather than build, bust, rebuild mentalities. The purpose of these series that we're hosting at Code is to provide an overview of modern principles and practices when we think about everything that is product and product thinking. And I guess ultimately there's a set of key themes that we're going to be working through. The session that we had a couple of weeks ago by Louis, which you can watch on YouTube now, on catch up, was around product management. Today's session is around modern engineering. And then we've got a couple of sessions on design thinking and design doing, and then we're into measurement and optimization and lean delivery. So again, these are concepts that I think everybody in a product team mentality should be aware of. But more importantly, it should be something that you don't just specialize in design, so don't go to the design one. I think everyone in a product space should be aware of all of these skills that a product team should be doing. So, skip back. So house rules, obviously, if you've got a question during the session in MS Teams, just add your comment in and we'll come back to it at the end of it. And if we have some time for open questions, then raise your hand by all means, use that option and we'll hopefully, we'll come to you. Post session, it'll be available on YouTube, so you can rewatch any bits or any of the graphics will be available for you. And again, if you want to comment in the YouTube comments. For a bit of housekeeping, mic and video, keep yourself muted for now. If you want to keep your video on, that's cool as well if you want to show your lovely faces. But if you don't, then it doesn't matter, you know. Respect everyone's privacy, of course. And just perfect on timing. If you hear some tapping, it's my dog deciding to have a walk around. Fantastic, thank you. Okay, so let's kick off with this week's session around modern product engineering. I guess who it's aimed for? Anyone with a keen desire to understand another asset of product thinking. So you don't need to be a technical expert, and if you are, this is a nice summary and a nice way to articulate some technical concepts to people that probably aren't technically minded. But it's people who want to understand a basic awareness of some technical concepts and engineering approaches, things that you might think, yeah, we don't do that, or actually we do that, but we keep falling into this hole. And obviously from a product team perspective, it's good for stakeholders, at any level, product managers, product owners, UX and D, anyone that's in a team effectively. Is that we're going to learn today, or hopefully go over some understandings of traditional development practices that I've seen in my history in software, and how some of those practices really do impact the long-term product adaptability. So why it ends up in problems further down the line. Hopefully we'll gain a basic understanding of some modern concepts in engineering, and I'll do that. And again, technology shouldn't be complex, it should be easy to understand. So my job is to make it easy for people to understand and relate to. More importantly, why modern engineering is a fundamental part of product thinking, and these are the things we should be taking away into our product teams. And maybe some routines and processes that I would recommend that you adopt to maintain that product approach inside your business. For anyone who's just joining us, obviously we'll be able to catch the start on YouTube later if you want to, but welcome to it. Okay, first thing, let's get honest. If it's technology, people tend to get scared if it's not in their natural field, but it's only technology, it's not rocket science, so let's not be too scared about it. Okay, I'm going to start with things that we see traditionally in traditional development practices, things that we see go wrong many times before. And we've all seen this picture many times, I'm sure we have, and we laugh about it and say, yeah, that's about right. That's what the UXD guy does. That's what delivery do. Yeah, that's what that engineer built over there. And we laugh about it, but in reality, it can be very true. And that normally happens because we're quite siloed in the way that we work as an organization, as teams, as individuals. And we're not really thinking about the product at heart, so we can all come together to solve it. But two core themes why software does actually fail, as far as I'm concerned. So it's a choice of tactical versus strategic technology choices. So tactical software is used mainly built to do X, a function, a thing, and that's okay, but as long as it's understood that it's tactical and it is a build, bust, rebuild, throwaway mentality. Tactical should define an end of life, and yet too many businesses continue to try to use tactical solutions to fit a strategic plan, and wonder why they get unstuck. Secondly, software, or the output of software, it's a symptom of all its inputs. It constraints people's capabilities, opinion. Everyone knows that it's not just the engineers that build it. Software has many constraints. Most of them caused by us, the squidgy human things, water-based items sat in the seat. And more importantly, the fault really lays with anybody that's in that space. Just shouldn't just sit with engineering, which it can easily sit with, blamed into an IT team or blamed on a bad design or something like that. But ultimately, software fails because of everybody's input into it. I use this as a way to try and articulate thinking about this cost of ownership or cost per change, which is related to the tactical versus strategic technology choices. So where we've got this curve here, where cost per change is really low and it's very attractive in the early parts of our development and delivery. It looks attractive where everything's going great, but normally we've done this because we're making some tactical choices. We're using some very simple, some box technology and maybe some free add-ons, so we can be quite feature rich very early on. And over time, we normally see that this curve of complexity starts going up. So the cost of ownership goes up, it takes longer and it's harder to get things released. The cost per change goes up because we end up with more, again, the complexity of it goes up, but we end up with things dropping off and failing and breaking in production. And ultimately we end in a point where it's kind of like wading through very thick mud for people to make change. So it becomes something that we have to throw away and start again. And this is normally applied because we haven't applied engineering practices to the way that we engineer a product. We've just kind of very organically built on top of it. So I'm going to explain some of the practices, why that happens, and then we're going to move on to how do we stop it happening effectively. So I like to use an example from an architecture, when we talk about architecture, to use something that a lot of people can relate to, especially in a digital space. So a lot of people understand what CMSs are about, or they've used them, or it's part of your stack already. So I like to use CMS as an example about how traditionally people have used CMSs, and will explain the architectural issues that causes. And I'll use the term monolith because ultimately big box technologies are a monolith. So if we look at basic building blocks of a CMS, and again, this could be anything other than a CMS, it could be a CRM, it could be a finance system, it could be any box technology. But in a CMS, we have a content management element, which is this pillar. We have a content distribution pillar, which is normally known as an API or distribution pillar. And then we have a content delivery, which is the front end web application. And then we have customer engagement, which is the bits that the marketeers get really excited about these tools to profile and personalize and test. Now, CMSs in our industry tightly couple those pillars, which should be kept independently, but they couple them because you get up and running really quick when you use them like that. And they effectively tightly couple those pillars together at varying levels, either all three of them or even all four of them. And that's what creates what we call a monolith. So if we use an open source CMS, and there's a plethora of open source CMSs, most of them do content management. They have an API, but most people don't implement using an API because they want to use the widgets that you get for free in the web in the website side of a CMS. So they can use kind of I don't know, like maybe a hero image or a some kind of carousel or things like that. So these are things that people use built in from CMSs that tie the content management to the content delivery, omitting the API layer. And it allows us to still use maybe best in breed customer engagement, because these open source CMSs aren't experts, or they don't offer that customer engagement tooling. But then we go into some enterprise level stuff, and you've got a variety of enterprise tooling that will then offer that additional customer engagement item in their toolbox. Sadly, that now tightly couples all 4 pillars, and again, omitting the API layer more than anything, which means that we've got another monolith. And anyone who's worked with any CMS generally will have an experience where they've had to rebuild it within a period of time. They have to start again. And there's a lot of reasons for that, and we're going to kind of cover it off. But also, another architectural concept is just because you can doesn't mean you should. So I've seen in my time over many, many years is that people use CMSs to store customers, users. That belongs in a CRM, but they use the CMS to do that. They use the CMS to control the UX, and that's quite bad, because it means we're not actually allowing the web application to control the UX journey. We're allowing content editors to control the UX. People use the CMS for e-commerce. They use a plugin to do e-commerce and sales, which ultimately means we use the content structure of an article. We kind of abuse it with a plugin to act like a PIM. So we use it to store products, which effectively is just content stored in a different format, but we're using it in a content management system. So we're abusing the purpose of the CMS. And again, we use it for personalization and performance and optimization. Again, these tools aren't best in breed from these people. So the people who are best in market provide these tools as a SaaS option. So why would you embed yourself with a CMS that provides them when they're not that good? And I've actually seen people use their CMS to allow their call center to log into, so their call center staff can manage customers and orders and products. And that's actually inside a CMS, built in the admin function of a CMS, where editors just normally edit content. They allow their operational staff to log in and perform operational duties. So just because you can doesn't mean you should. And these big box technologies normally come with very dependent version control. So there's normally 20 or 40 upgrades a year. Nobody does them until the big security patch comes out that you must do because you need to stay compliant. And that normally ends up in a break. So you've used your version X of CMS with your plugins and components and business integrations you've downloaded from your marketplace, and you upgrade it to the next version, and you generally will break any of these things that you've done, either because the integrations have slightly tweaked, or because that actual integration or that freebie does no longer work with version Y. So you have to throw it away or spin up another CMS so you can then continue development using a safer CMS for pages that you need to. And I've seen in some cases some businesses have had 4 CMSs running at the same time, purely because they couldn't get out of this model, didn't understand what it meant. So understanding architectural concepts about big box and monolith is one reason why it gets you on that cost per change curve. And that ends up normally, like I said, between 12 and 36 months, you end up in a quite a nasty position where you're back in market again, looking to rebuild it. So I'm going to move on to some basic development practices now. Some of the myths around some technical terms, and I just want to make it really clear so you feel confident in some of this. So testing, if we think about testing at its basic level, there's different kinds of testing that we do or can be done in technology. So right at the bottom, we've got unit tests. Unit tests are normally done at a very granular level, done around a single responsibility piece of software or bit of code, normally at a very low level, testing one thing. And you write lots of those. So in that triangle, there should be lots of tests, lots of granularity, and they shouldn't take long to write. And the return on investment is actually higher on those because you get faster feedback all the time on those. Integration tests are where lots of unit tests or code comes together to integrate together. So we write a unit test around how code then acts together and interacts with each other. And again, those integration tests should be useful in the way that we write them and relatively easy to execute, and return on investment is not too bad, knowing full well that code may change and integration may change. So we'll probably have to change some of those integration tests. And the hardest part is functional tests. And these are normally, when people talked about behavioral driven development or browser testing, normally an automation in that space. Functional testing is very much the user experience, probably, or the functional checks. Now they get even more expensive to write, but they end up being very brittle because as the UI changes, you probably need to be changing those functional tests. So you get less return on investment from those. And therefore, you should probably have less tests in that space because you know they're going to be brittle and you're going to have to maintain them. So there's some differences there in the kind of tests that we do. Now, how developers use these kind of ideas about how we test, really, if we go into this model, we understand that there's a problem and an output that we need to create. So the developer understands the problem and what's needed, well, their concept of what's needed. They then implement the feature in software. This is generally what developers used to do, and in most cases still doing today. And then they write some tests around the outside of what the software is doing. There's a problem here. I hope people may be spotting it. Not that you can shout up. More than welcome to comment or ask questions in the chat, of course. But the problem here is, I don't know if you can see, but number 3, it's flashing because we're writing the test after we've written the software. So the software is down to the developer's interpretation of the needs and the problem and what he needs to develop. So he's implemented what he feels is the right implementation, and he's written a test that reinforces what his implementation has done. So it's a self-fulfilling test. So he might have implemented not quite correctly, but the test is giving him a positive feedback, so it's a false positive. And that's a big failure. So when people talk about we write tests, and yes, we write tests and we do TDD. TDD is a term, test-driven development, whereas that approach is actually development-driven tests. So we've done development, then we write some tests. So I like to use an abstract example to make it really clear. So let's say a developer implements some software, we'll call he's created a square. That was the requirement. So yeah, he's implemented what he believed was a square from the requirements, and then he writes a test around the outside of that square to reinforce it's a square to him. However, closer inspection, it's not quite a square. We've written one test to try and prove it's a square. It hasn't got a right angle, and are the sides the same length? Have we really made a square? We've only just written one implementation and one test, so that test isn't really strong enough. It isn't thorough enough. The problem we have there is that in a product mentality, when you then need to try and adapt that square, because our business no longer sells squares, our clients or our customers want rectangles. How do we then change that? If we were to change that into a rectangle, what a developer would then do is alter the implementation and make it a rectangle, or what he believed was a rectangle, by altering the code. Then he'd ultimately probably delete the test and write another test around the outside to say, we sell rectangles now, I've made you a rectangle. And the issue we have here is that the same problem still exists. We've probably got imperfections, some things that aren't quite right in the implementation, but the test is just a self-fulfilling test that's giving you a false positive. And that's a huge problem when we come to software engineering. That's why products end up breaking very easily, and we end up with this mentality of, yeah, we write tests, we're doing TDD, but as we've seen there, that isn't TDD. What actually we're doing is DDT, development driven tests, and tests tend to be low quality. So we call them, if they don't have the granularity, so they're not testing enough actual detail and tight enough, then they can be quite opaque in the testing. So ultimately, a lot of scenarios aren't really caught. So the test is quite thin, and it means you can have a high test coverage, but the tests aren't of value. So that approach to testing ultimately leads us down the path. Leads us down the path of creating this high cost of ownership, cost per change, because every time we make changes, something probably breaks, and we've got this self-fulfilling prophecy still existing in our code. I want to move on to some traditional QA practices. And I guess the role of the QA is to check it works, yeah? That's what the role of a QA is all about. Well, it still is for a lot of people, but I don't believe it should be. So how do people still use QAs? Well, we've got a dev team that do a load of work, and they probably, we've got a load of requests, and I've written the implementation, I've written some tests, we've got some automation. And then we hand it over to the QA team to test. And the job of the QA is to find the bugs. And then the QA team pass it back to the dev team when they found the bugs. What we end up with there is actually a list of bugs because they may be bugs, but also a lot of bugs that are opinionated led bugs because a QA has a belief that it should do this instead. The QA also in this model, and I still see it today, are incentivized to find bugs, not incentivized to increase the quality. So the more bugs that we find, the better we're doing, but also all we're doing is going around a loop of development QA before we get a product to market. And our responsibility as product people is to get a product out to customers as fast and iterate on that product as much as we can. So this model also might mean you might end up releasing some software that works at the end of it, but it'll be slow and it'll take a lot longer. It's less collaborative. And again, this approach puts you on a red line. So I want to go through some modern engineering concepts now within a product environment. I guess everyone's seen this one before, but I think that it was originally said there's 2 certainties in life. I think there's 3, if we're being honest. Yeah, death, taxes, everyone knows that. But change, it's inevitable. Everything is changing every day. I mean, look at the world that we live in today. Who'd have thought we'd be doing this this time last year? I know I was thinking about going abroad for a week, and look how the world's changed now. So change is inevitable. So what is a team's responsibility to software and the products that they deliver? Firstly, it's to use software to solve the problem. That's a given. That's what we do. The second part of this, after the and statement, is the bit that's usually forgotten, and it's to leave software in a state that's ready and able to be adapted. So we can adapt it for tomorrow's unknown problems, and that's the bit that we don't normally do. That's because we use those traditional practices quite a lot in the way that we develop software. So it's somebody else's problem to pick up, and they'll have to refactor that code and do something else. So ultimately, a team's responsibility is to leave that software in a state where it's ultimately able to be adapted. Now, this isn't new. That statement ultimately comes from things like the Agile Manifesto that's been around probably longer than I've been around, it feels like anyway. But that manifesto is all around having working software, being able to adapt to customers' needs, responding to change. So it's how we think about it, we engineer. It's a really important part. But then manifesto, from an agile software development perspective, then moved into other disciplines. So we've got a testing manifesto. If you do your digging, you'll find that people now think testing is a phase, not an activity. And that's the way I think about it. It's about testing throughout rather than testing at the end, preventing bugs over finding them, testing understanding over checking functionality. And that's if we're testing understanding, we should have clear acceptance criteria and be validating the acceptance criteria rather than just testing something at the end, and build the better system over trying to break it. But ultimately, QA is a team responsibility that should have a specialist that drives QA capability in practice. And that QA person might do the edge case scenario testing, but ultimately driving a quality-led product team who think about quality in a different way, quality first. So testing as a phase is something that we don't do. Testing as an activity is something that we absolutely should be doing. If you're moving into the product space, so Melissa Perry probably made a name for herself probably 6-7 years ago now, talking about product and how we need to think about as product owners, product managers, product people. And she came out with a lean product manifesto, and she's been talking about it ever since, and she's released quite a few books. Yeah, people who've read it. But again, this thinks about how we need to think as a product team, not just the product manager, but the team. And it's really important that we think about these things. So having all these ways of thinking about manifestos and our thought processes led Code, and it should lead you as your businesses to think about what's your manifesto, what do you stand for? Have you got a clear understanding of what you're trying to do? So as a product services business, Code have to try and show that we're aiming to drive change for our clients, but we want to do it in a collaborative and transformational way. So we do stuff on the left. That's where we want to get to. That's the end goal with our client relationships, versus maybe stuff on the right, which might be very old school, traditional digital agency methodology, where you just predefine the solution you need to do. It's a pretty design that you do a project delivery, and it's the amount of bells and the whistles, because of those bells and whistles were probably defined by someone's opinion rather than any insight, and a very big bang. Ultimately, you end up with constraints. Whereas on the left, it's very much around, right, let's identify the problem space. Let's make sure it's a customer experience first over a design, that we have a product approach, because we can iterate and deliver value through insights. And if we do that, we're more adaptable. We can create adaptability as a product team and as a business. And again, how we lay ourselves out as product teams is really important. So it's about having cross disciplines sat together, working together, who, yes, you have your specialism, but everyone should have a slight understanding of somebody else's. You don't want the bus syndrome when somebody gets knocked over by a bus or goes on holiday and all of a sudden the team have to stop. That's not the action of a self-managing team. So a product team should have that understanding of each other's roles and responsibilities, so people can pick up the pieces when someone's not there. Not quite maybe to the level of expertise, but enough to be able to manage for a short period of time. I guess when it comes down to engineering, we need to have clear standards and expectations, and hopefully you've got these set inside of your business. And for me, it's not around lengthy documents so much, it's around having very clear pillars. So what do you stand for as an engineering culture? So I guess the engineering opportunities I've created, or the engineering departments I've created, it's around using the right tool for the right job, but also making sure that we don't employ every technology under the sun. It's around architectural loose separation and loose coupling, which gives you increased security. And as we go through some of these are some of the pillars that we aspire to keep as a business. Some of the most important parts of that is test-driven development, understanding how we can automate and do true TDD. And I'm going to explain what true TDD would look like, so you feel confident in it as well. But ultimately, we're creating rapid feedback and we're using modern Devops. All that kind of stuff is so we can, as a team, we can own the product and we can drive it forward, and everyone understands it. In the teams, teams should be aware these days from GDPR and PCI. There should be an element of awareness inside of that. So are your teams being trained around secure coding? Do they have annual refreshers, that kind of thing? So everyone from an engineering perspective should be aware and going through some level of training, because the GDPR and PCI is everywhere. Everyone needs to understand the potential risks, because that will help us identify better testing capabilities, better automation capabilities, which ultimately, if we plug into our CI environments, we get faster feedback. So we don't have to have quarterly or annual scans that we get a report and then we have to fix a load of things. We should be fixing them faster, learning faster. So again, modern decoupled architecture. Ultimately, again, these are some of the things that I believe in. We have an element, if we think about right at the front end, we have customer experiences. These should be really easy things, whether they be web applications, whether they be apps, whether they be voice, or whether they be any other digital experience, maybe even an internal tool that we use inside the business, maybe a call center tool or something like that. But ultimately, all of our business systems, we should expose up through APIs, and then we can effectively create whatever kind of user experience at this end, because we're exposing all of our business systems data up through what would be a microservice API or events model. That approach then allows us to adapt, because as the business say, we don't want that CRM anymore, we're going this way. All we have to do is swap out. If business system 2 was a CRM, we can swap it out, change the API, and everything that looks in just sees the same external view, so we can continue to work as we were. So we don't have to replug all of our customer experiences back into a CRM directly. So we're abstracting ourselves or obfuscating ourselves from business systems, creating that level of independence. And again, it allows us to maybe think about what technology we use at every layer. We can react easier to technology because it's less tightly bound to business systems. So we can think about that, and that's part of our technical strategy. So something for us to think about. Okay, so when we get to deving, what is TDD? Let's talk about that very quickly. So I want to get into an abstract example. Using the example of the square that we had before, devs want to do or build a square, that's the requirement. The first thing they would do is write a test. And here I'm going to write a test for a corner piece. So that we'll write a test. As soon as we write the test, it's failing because there's no code to actually say I've implemented it. So the test is red. Then we write the implementation, and all of a sudden the test goes green. So that's the first part of, we've got one granular level of test for a corner piece. Then we do the same again, red, implementation, and green. And if we continue to do this step, we end up with a suite of tests at the smallest level, where we end up, if I fast forward, 2, that's great, done. I can then write an integration test, but I've got my implementation. And we've got a set of tests that have been done first, so we know it is exactly a right angle, and we know exactly how long each corner piece, each piece is. It's a real square, it's exactly what we requested. And that's fantastic. But the most important thing, that when you need to adapt that and change that with our product mentality, because our customers want rectangles, no longer squares, we can break that integration test purposely and delete it. And all we've got to do then now is we can delete some code, but we can implement some new code. It's with implement a new test first, implement the code, and it goes green. Can delete some code, write a test, it fails, write the code, it goes green. Rewrite the integration, and off we go. We've got an implementation again. So that adaptability is what TDD is all about. That's how we create adaptable products. But it's all too easy for those adaptable products and that process to sometimes fall by the wayside, and we end up doing implementation and a test around the side. So although we're trying to stay off that red line, we might create this blue line. You can see that the blue line might go up, and that's about us making sure, are we maintaining our processes and standards from an engineering point of view to get them under control? Because if you don't, you can then end up back on a red line. If you start off with a clean application that's written well, but over time you remove tests, you start doing the traditional development practices, probably through capabilities of people and who you're onboarding onto the product, which is, it's usually the case of people just aren't aware of how to code it, so they just do what they know to do. One of the other questions that we talk about, and it's really important on this is something that I think everyone has a huge responsibility in, understanding what technical debt is about. So we've talked about before, effectively it's all about creating products through adaptable and sustainable engineering. It requires a fine balance of delivery and software quality, and that's a balance that you as product people, whether you're delivery people or whichever, have a huge responsibility in. Otherwise, technical debt is easily created if it's not managed correctly, and that becomes normally somebody's problem, not yours or not stakeholders. So it's very easy for that to break down the quality of that product over time. So talk about the balance of software and delivery. 3 core themes I like to embed. Debt should not be added to the code base that we work in. Simple. If debt is added, because it can be for valid reasons, maybe we've got a delivery deadline, we've got something we've got to hit in 2 weeks, that's fine. These things happen. But then the team and client or stakeholders in this case need visibility of it and own it, because this was a delivery-led maybe debt that's been created. So then a plan needs to be created and prioritized to repay the debt. It can't just be forgotten about or left, and the stakeholder can't walk away to scot-free. It was the stakeholder on the delivery needs that drove the debt, so that ownership is on that person. If existing debt exists and hasn't been paid back, but it's slowing us down in our current tasks, then it needs to be dealt with there and then. It needs to be prioritized and understood. And again, if we defer it and we just leave it, it's going to get harder to work, and it's going to impact the team's efficiency and ability to reliably code. So we need to create that plan. And then finally, there's dormant debt. So it's a silent killer in my opinion. This is the bit where if we just leave it, it's not in our day-to-day stuff, it's not affecting us right now, but it's going to get worse. It slowly over time kind of makes walking through water turn into walking through mud, where it gets harder and harder to make change because we haven't dealt with some core debt that is really affecting us. And as our solution gets more complex, some of that debt starts creeping into it starts affecting us more and more because the system complexity has got bigger and wider and grown over time. So I use an example that when we talk in our teams and we talk about maybe an estimation. For example, we've got a scenario here that we're discussing a feature need and the desire, the opportunity of speed to market and the investment appetite. Most teams just give a single measurement, like what is it? It's either time or a complexity figure. You know, we think it's, we've done our planning poker or whatever we may have done, and we think it's a 2 or a 5 or a 3 or a 1. Or some people might still be using measurements of time. It'll be 3 days. But we should also have indications on a sliding scale of what we think we could do. So maybe we should think about scope as well. Do we reduce scope? But ultimately, we've got options. So the first one is gold plating. And I don't ever condone gold plating or over engineering. It means there's no debt incurred. Clearly, they're looking for an award for the best engineered product. But ultimately, it will take a lot longer. So let's just say an example, 6 to 8 weeks. Then we end up with gold plating. Engineered well. There's no debt. It's not over engineered. It's the sweet spot, really. It's where we want to be in a product engineering world. Let's say it was 4 to 6 weeks as an example, whatever complexity that may be. Then we end up with some small debt, maybe deadline driven or investment driven. Maybe we didn't have enough money to support the deliverable, or the deadline needs to be quick. Ideally, to stop the debt happening, we could look at the feature and try and slice it, so we can maintain an engineered well product. But if we have to do full feature, then it's 2 to 4 weeks, but we're going to incur debt. And then as we go lower, we end up with heavy debt, usually driven for just get stuff done very quickly. It needs to be tactical. This will impact the effectiveness of future product development, but ultimately you might get something to market in 1 and 2 weeks. So there's like scenarios that we need to think about when we talk about some of the debt that we might cause. So technical debt, we know this debt payback curve, it's not linear. So for an example, a 4 to 6 week to do it right, to be engineered well, and 1 to 2 weeks to go fast, doesn't mean a 3 to 4 week debt payback. Largely, most of those cases might have to throw it away completely and start again, or to refactor and re-engineer it up to a good standard. It might take a lot longer. It might even actually take the same amount of time that we originally estimated to be well engineered. So, because it's just not linear. It's not like, well, you had that amount of time. There's a lot of debt to pay. Obviously, the longer that the tech debt stays in place, it becomes the more cost and effort it'll take to pay it back. It's the old payday loan effect. So it's about getting that debt prioritized and paid back, and having clear ownership on the debt. So it's, you know, if the dev team made a mistake, that's fine. We all make mistakes. If it was driven by a deliverable or investment, somebody still has to own that, because ultimately someone's got to carry that risk forward. And it's really clear that people need to take accountability. And in a lot of cases, we find stakeholders not really taking accountability for commercial decisions, either investment or timescale. And it's about making those people very, very clear on their accountability in that. And obviously we've said it before, but the final side effect of debt is that it's very hard to articulate and quantify, but the code base gets harder to work in, so devs it takes longer to make change, probably because we haven't written the test correctly, because we got it out to market quickly, and we end up very easily on that red line of our cost of ownership and cost per change. So we've got to be very careful there. So even though you can end up, you can start on the blue, you could end up on the red very easy. Just about nearly wrapping up. We talk about modern DevOps and the automate everything approach. And I just want to cover off where we started from. I mean, when I started in this, we had servers in the back office in a little room, and you had them on-prem. That was traditional hosting more than anything. Then we went to private cloud. People using service providers to host and manage services, but they were still largely either physical tin or VMs that sat on physical tin. Now, I know things don't actually change when we move into our cloud subscription models, but ultimately it's far more scalable, and we've got the option to start using more SaaS products and SaaS services where we don't have physical machines or the ability to log on to physical machines, because they don't really exist. There are services that are built as code and infrastructure that's managed as code. So everything's done through software. Gives you less ability to tinker with it, which is great, because it means that everything then becomes more repeatable, and everything is run through software. If it's created through code, it's repeatable all the way through the dev environments, all the way through to production. So obviously that's the market that where we should be going when we're thinking about perhaps stability and ability to scale and react to new stuff as it comes out. If we architect in a decoupled way, then we can take leverage of not installing, for example, Elasticsearch on a server, but using Elastic as a service in AWS or Azure. Obviously, we talk about DevOps. It's really clear that DevOps is that marry of capabilities of product development and operations come together, so teams own their own environments, their own systems and ability to make change, rather than handing off to an ops team who will do the rollout and deal with any level 1 or basic kind of issues. If the team don't feel the pain, the team ain't going to do it better next time. So ultimately, we need to make sure the team start taking more ownership for what they're doing every day. I use this, I don't know, it might not come through on video, but obviously we are the humans, we're the ones that make mistakes. But ultimately, if we can automate everything, we can take us out of it and we can use our time to do the things which is solve problems rather than replaying task-based items and just doing tasks, because that's not a good use of our time or our brains. Finally, if we automate everything, we obviously staying on the blue line, think about DevOps and our infrastructure approach. So there's a couple of routines. I'm very quickly going to run through these because we're nearly out of time. So these are maybe routines that you should be having inside your product teams or at business. So some of these routines would be, do you do regular diligences of your products and your business from a technical perspective? Do you do this? I mean, really, it should be done every 6 months or 12 months. And this is a good way for everybody to understand the current state of your product, or that software, or your business systems, based on best market conditions, or what we expect the market to be. Do you do North Star? So this is where we start thinking about, bearing in mind what we know and where we want to be as a business. What's our technical aspiration? Where do we want to be? It should align roughly, or allow the ability to enable changes in your product roadmap and facilitate those changes. So if we architect for what we know today, it's probably not going to be right for tomorrow. So how do we create that adaptability in our architecture? So having a North Star allows us to maybe think about where we want to go and head towards it, but understand that we need to pivot as well. And coaching. So how are you ensuring that your skills are fresh, or your team's skills are fresh? Are you investing in those people correctly to make sure that they're at the right level? If you don't, it's no wonder things are going to regress and you're going to end up potentially on a red line because you've got people in who don't really understand. So are we investing in our people through correct coaching? And so very quickly, as a due diligence, I've explained why it's quite useful. Generally, most people or most businesses, it's a day-to-day, things evolve organically, and that's fine, but we've got have to have an element of review, and we should have a review so we can view it and play it back and show the business. So as an example, you should be having things that cover off various elements of your estate, and these should be things that you as product managers should be able to see, because this is the risk you're carrying. You should be able to say, whether we're green or orange or red. So actually, well, we need to deal with that then, don't we? We need to find time and do that. That needs to be part of our product strategy as well. If you don't do these kind of things, then it just grows organically out of the way. Obviously at Code, we can provide this service as well, but ultimately it's something that you should be doing internally. And not for companies that we help do this for, they take it on as an internal process and run it themselves afterwards. And as a routine, it's really, really valuable to make sure that the tech platform is being moved forward rather than just maintained. As an example, it goes into a huge amount of depth around what we do, and this is the kind of like level of detail we should be doing, understanding everything from a state, a risk, and a recommendation point of view, which can then drive a short-term roadmap of kind of like high-level must-dos. As an example, that should be in your product backlog. If we think about a technical North Star, this is the view of if we get caught in the day-to-day, reacting to change, then we end up with a system that it's very hard to adapt longer term. We end up with that kind of constraint and that build bust mentality. So ultimately, the North Star should be something that identifies a technical strategy and a way that where we want to be as a business. How do we create teams and retain our staff, because we've got the right technology being used in the right place at the right time. So it's ultimately, it might create some employee proposition as well. but having a clear tech strategy means that the decisions we make are very clearly either tactical or strategic. And when we have to make a tactical decision, we know that we're not going to progress towards our North Star, and it might cause some debt. And it helps communicate this a little bit clearer across all levels of the business. So we do some work with, we've done ranges of work with a set of clients where we help define some of these technical North Stars, and that helps them to onboard an internal team and continue that philosophy internally. And that North Star might even be some kind of articulation of how do we break a monolith down so we can start moving that business forward into some of the new opportunities that they want to in line with their customer experience roadmap. So how do we introduce, I might break down a traditional CMS into nice business systems and API so we can effectively create a better system for them. And this is ultimately starts becoming the technical roadmap that might last 2 or 3 years. But it's the aspirational part of it that we can then adapt when we need to adapt because we decided we're going to go in a different direction. And again, we help clients do this. And then again, it's a routine that should be embedded inside of your business. If you're not doing it or you're not aware of what the technical strategy is, then that's not good because you should have clear technical strategy. And then from a coaching perspective, you should be thinking about how are you doing that coaching stuff? Are your dev leads had the coaching around process, and do they understand what they need to be doing from team routines and being able to train the trainer so they can train future dev leads? Software engineering, are we doing TDD coaching? Are we doing refactoring patterns? Do people understand how to do these things? And again, training the trainer so you've got experts in your business that will do this moving forward. And we should do it across all elements of our technical capability inside the business. So are we investing in our people? So I strongly believe that if we do a lot of those things, we stay on a blue line. And it's always a hard battle. So sometimes that line starts to rise and we need to raise the profile even more. It might be time for another technical review or diligence review to make sure something doesn't feel right. I think we're going off track. Let's review. Let's communicate our red items, our must-do items, and let's make sure that our North Star we're still pointing towards it. If not, then we need to pivot. We need to invest correctly or adjust the product roadmap. So very quickly, it isn't really nothing to be scared about. Our job from a technology perspective is to make the product aware. I think so. I remember someone saying that rocket science isn't really rocket science. It's just ballistics, really. It's just it makes it sound cooler when it's rocket science. Is there any questions? There's nothing in there at the moment. Oh, Lisa posted a question. Just in time. Everyone can see the question in comments. So yeah, understand the points of technical debt, but how do you balance this with solving problems and being lean? Well, solving problems isn't just around solving customer problems. Solving problems is solving problems that within your product space. So a lot of people think that the product roadmap is all features, and a product roadmap is actually made up of 2 things. It's a feature roadmap, a customer roadmap, the things that you're trying to deliver, and also a technical roadmap that needs to align to it. And the 2 need to be balanced together to create a product roadmap. A lot of people ultimately kind of go down this path of I've got a product roadmap and someone needs to take care of the tech, and therefore it never really gets any time. It never really gets a space at the table. So then you end up with we'll do a month focus on tech to keep everybody happy, and we think that's enough. But actually, product is around balancing feature and technology, so we end up with something that's sustainable, that delivers the customer needs. So that's ultimately where I see it going. Does that answer your question there, Lisa? If she's still here. Maybe not. Okay, thank you. If anyone's got a question, by all means, raise a hand or shout up. You can come off mic and shout up if you want to. If not, that's cool. Like I say, this is a very light touch entry into some modern engineering, and when we do some of these sessions that we've done before with other clients, we go into a lot more detail from a technical perspective, going into real depth on engineering cultures and maybe how we create scalable engineering capabilities. How do you create teams and structures? that kind of thing, maybe around even capability matrix and things like that. We start going into real, how do we understand our roles, and I guess how do we progress people, how do we create that ability for people to progress in a business. Okay, so what's coming up? So we've got a talk, excuse me while I get my notes up. So we've got a range of code talks that are coming up. The next one is how to create effective digital teams. Ian, have you got the exact date for that? I think it's Thursday the 4th of March, is that right? Which you can register for now on the website.
Yeah, that's right.
Yeah, brilliant. And again, we did a recent code talk only last week. I think you can get that on YouTube as well. The next product fundamentals session that we're going to be doing in the Product Love series is design thinking and design doing. That's on the 17th of March. So that's going to be a kind of a crash course into product design thinking and design doing. So that's a really interesting session. We normally do 2 sessions for this, but we're kind of crashing them into one to give you an intro into the things we need to think about from a product perspective. All the rest of our events are on our website, codecomputerlove.com/events. So please go to have a look. If there's anything there, please sign up and register. If you've got any questions, of course, then by all means send us comments. I think my email address might be on the site, but by all means send an email to us or comment in any of the channels, and we can have a chat, and I might be able to support you. But that takes us pretty much to the end of today's session. But if anyone's got any questions, you've got a couple of minutes now to shout up. Otherwise, we'll hang up.